Okay, and now we're taking a look at problem 8. We had to use this picture to uncover some kind of patterns in sums of integers, right? We had to find the sum when n equals 5. Here, this was n equals 1, right? Where we have one integer. 1 plus 2 is when n is 2. 1 plus 2 plus 3 is when n equals 3. All right, so what about when n is 5? Well, we would just have another 4 and then 5, so another 9 here for this total, right? When n is 10, same kind of idea, but maybe what we can do is actually figure out some larger pattern so that we can do this when for the big number, like when n is 100. And as we discussed in class, if you notice something about the geometry of this, we could take one of these sums and kind of turn it upside down, and we end up with a picture like this, right? Where this guy is also. And we can count these very easily using our earlier ideas from area, right? Like the area of this plate is 4 times 3. If we look at the same thing over here, right? It's 3 times 2. And here, you know, I mean, this is kind of, but this is 2 by 1. So one side is always going to be the actual dimension, and the other is going to be one more than it, right? Same, like we can just see that this idea would extend to any geometry. So the area of these is just n, whatever n is, times one more than itself. And because we're only interested in half of those pieces, then we'll just divide this by 2 and we get our sum. The consequence for that is that for n equals 5, we're saying that that's going to be 5 times 6 divided by 2. For n equals 10, that'll be 10 times 11 divided by 2. And for n equals 100, that'll be 100 times 101 divided by 2. And great, voila.